You are watching the 8.7 lesson video on solving real-life systems algebraically. So I want to talk about how word problems are solved. And in order to solve a word problem, it's very important to make sure that the question is set up before you try to answer the question, because 9 times out of 10, it will turn into a disaster if you're missing the setup. So we're really going to focus on making sure the question is set up first, and then continuing on with coming up with equations and then solving the system, and making sure that the answers, of course, make sense. Okay, so what do I mean by the setup? Well, the setup for me, the most important part is having let statements. And what's a let statement? Well, basically, it's reading the question and figuring out what is missing, and then giving your unknowns variables. You should never, ever, ever try to set up an equation without telling the reader, or really yourself, exactly what the variables mean. Because when you know what they mean, then you can go back and verify and make sure that the pieces to your equations actually make sense. So read question number 1 to yourself. And you are going to realize that we're getting a job, or you're getting a job as a camp counselor, and you have to buy supplies on 2 days. So on Monday and the next day, you're purchasing soccer balls and footballs for different prices because you buy different quantities of each on the 2 different days. And then it asks you, as the final question, let's highlight this here, how much does each soccer ball and each football cost? Well, from that sentence right there, I can actually get my let statements. So I'm going to just use x and y. X is equal to, well, we don't know 2 things now. So we don't know the cost of a soccer ball, and we don't know the cost of a football. So x is going to equal the cost of a soccer ball, and y is going to equal the cost of a football. Now that we have our let statements, it's okay to start writing the equation. And you might say, write the equation with labels. What does a label mean? Well, I like to always label what the equation represents. Does it represent the total cost? Does it represent the quantities of things? Does it represent days of the week? So, reading in our problem up above, it says, on Monday, we purchased 8 soccer balls and 3 footballs for $152.50. We know that the total is $152.50. And what does this sentence really mean to me? Well, it means on Monday. So I'm going to just call this equation the Monday equation. And on Monday, the total was $152.50. Now, we have to be careful with making sure that our units are all the same within each equation. So for example, this 152.50 is money. So all of my terms on the left-hand side also have to be in terms of money. I can't ever have like number of something equaling money. That doesn't make sense. So you always have to have money equaling money. Okay, so we know that x is already in terms of money. 8 soccer balls. 8 soccer balls multiplied by the cost now makes this term in terms of money. Let's add the football onto that. There were 3 footballs, but remember the cost of a football. Now we've turned the quantity for 3 footballs into money when we multiply it by y. Okay, then the next day, so this is our Tuesday equation. What is happening? Well, on Tuesday, you have to go back and you purchase 6 soccer balls and 2 footballs for a total of $113. And that's 113 even. This equation is going to look extremely similar to the first one, except here we have a quantity of 6 soccer balls times the cost per soccer ball. We're going to add that too, because when we find the total of something, if you think about a restaurant, you find the total bill, you're just adding up all the values. So 6 soccer balls and 2 footballs is equal to $113. All right, let's go ahead and start solving. So when we solve our system, I'm first noticing that my 2 equations are written in standard form. So to me, I think elimination is probably the best or the better strategy, because if I use substitution here, I might end up with a lot of, oops, I made a mistake up here, didn't I? That should be 2y. So plus 2y. Okay, and as I was saying, I just don't want to deal with a lot of fractions or decimals within this if I use substitution. So let's use elimination. And, my variables or my constants of my y, or my coefficients of my y term, the 3 and the 2, they're smaller than the 8 and the 6. So what I'm going to do is I'm going to multiply them by the opposite. So since this is a 2, my top equation will get multiplied by 2, because I'm really trying to make the additive inverse happen. 2 times 3 is 6, and then 3 times 2 would be 6. And remember, we want the signs to be different. Right now they're both positive, so I'm going to make the 3 negative. All right, let's now multiply through. So if we multiply the top equation and distribute that 2 to every single one of our terms, we get 16x plus 6y is equal to 2 times 150, 250 is 305. Bottom equation, we'll get negative 18x minus 6y is equal to 113 times negative 3 is a negative $339. Okay, so now remember, we're using elimination. We add our 2 equations together, and that's how we get the y terms to cancel out. So 16 minus 18 is a negative 2x, and then 305 minus $339 is negative 34. Then our last and final step is to figure out what x is. So we have to divide both sides by a negative, which I'm thankful for, because otherwise I get a negative number or a negative cost of a soccer ball, and that would be weird. We have to figure out where the mistake happened. We find that x is equal to $17. Okay, so there's our x value. And our y value, we can pick either one of the 2 equations. I'm going to go with the bottom one. So 6x plus 2y equals 113. I'm going to leave off the decimals. I don't really need them. So this would become 6 times the 17 plus 2y, because now we know what the cost of the soccer ball is. And then we're just going to solve. So 6 times 17 ends up giving us 102 plus 2y equals 113. And then what do we want to do? We want to take away 102 from both sides, or I guess I could sort. Either way, we end up getting 2y equaling 11. And if we divide now both sides by our 2, we end up finding that y is equal to 5.5, which is really $5.50. Okay, let's not forget to answer the question. So up above here, it says how much does each soccer ball and each football cost? So let's say soccer ball cost is $17 because that was our X value. We can use our let statements to help us with that. And then the football cost is $5.50. And we've answered the question. We could go on a little bit further and check our work by typing this into the calculator and either graphing the lines, finding their point of intersection, or we could use the algebra feature on the calculate page. Question number 2. Here we go. So number 2 is dealing with a beads shop, and they're selling wooden beads and crystal beads, and they're each worth different amounts of money. And we know the total beads and how much she paid for them. What we're trying to figure out here is how much more did she spend on crystal beads than wooden beads. So that is where I'm going to get my let statements from. So how much more did she spend on crystal beads than wooden beads? So we need to think to ourselves, okay, do we know how much crystal beads are and how much wooden beads are? And the answer is actually yes. But the problem that we don't know is how many wooden beads were bought and how many crystal beads were bought. So that is where we will get our let statements from. So I'm going to say X is equal to the number of wooden beads and Y will equal the, what do you think? Yep, number of crystal beads. So now we have what our two variables are. Let's come up with our equations. Well, they gave us two important pieces of information. We know that there were 127 beads bought, and we also know that $41 was paid for them. So I'm dealing with two things here. I'm dealing with total beads, or the quantity of beads, and I'm also dealing with the money spent. So I have like a money equation and a quantity equation. Okay, so let's back it up. So the quantity equation, we know that the total quantity has to be 127. So 127 represents beads, so my units all on the left-hand side all have to be beads and beads, or number of beads and number of beads. Do we have that? Well, we sure do. Look at our let statements. X is equal to the number of wooden beads. Y is equal to the number of crystal beads. So if we're trying to find a total, what do we do with our values? Yes, you are right. We add them together. So X plus Y equals 127. Number of beads, number of beads, number of beads for my X, Y, and 127. So that's my quantity equation. Let's look at the money equation now. We know that 141, just plain old $41 was spent, but that's money. And that's another total, right? So typically we would say X plus Y equals 41. But here's the problem that I was talking about. X is a number of beads. So beads plus beads equals money. Oh, this is not good. We need money plus money equaling money. My units of all of my terms have to be the same. So let's read into the problem. Did they give us any more important information? Yes, they did. The wooden beads, 20 cents. Crystal beads are 50 cents, not $50. So how do I write 20 cents and 50 cents? That's right. 0.20, and 0.50, respectively. All right, looks like we can rock and roll with our solving now. I have both of my equations. So I look at the two equations and I need to decide, okay, is substitution or elimination best? And even though they're both written in standard form, my top quantity equation is x plus y equals 127. Let's start with that one. I'm going to write this just in a different color so we can see we're on the next step. So x plus y is equal to 127. Wouldn't it be really easy to get one of the variables alone on one side? Couldn't I just like move the y to the other side and say x is equal to 127 minus y? And I wanted to do this because I think substitution is a little bit easier. Otherwise, we're multiplying equations using decimals. I'm not really a fan of doing that. I mean, you can. There's nothing wrong with it. It's just I don't really like it or like to do that. So now we've got an x alone. Let's go back to our other equation, which is the 0.20 or the 20 cents times our x. But x now, isn't that 127 minus y? So we can substitute that right on in there. 127 minus y. And then just continue the rest of the way. 50 cents y is equal to 41. Okay, let's go with the solve now. Looks like I need to distribute. So 20 cents times 127, that's 25.4 minus 0.20. I'm just going to leave off the 0 to save some space. Plus 0.5y equals 41. Looks like I can either sort. I just need to keep solving. So I am going to just send that 25.4 to the other side. And then I end up getting, I'm going to sort. So negative 0.2y. Don't forget that negative out in front because it was minus. Okay, so nothing changed here. It's just a 25.4 moving to the other side. Next, let's just group them together. So I get 0.3y is equal to 15.6. And then lastly, we need to divide both sides by 0.3, or I should really say 3/10. So y is going to equal 52. And that would be 52, let's see, crystal beads. Okay, so now we know that y is equal to 52. I need to substitute this back into one of the equations. I'm going to go with the easier one, no decimals involved. So let's go back to, let's see, I'm running out of space, so I'll show this right over here. So this is kind of like my next step of the process. So x plus y equals 127. So that would mean x plus 52 equals 127. I can just take away 52 from both sides. And I get x is equal to 75. So let's answer the question. Is my answer 52 beads of crystals or 75 wooden beads? No, but I need this to help me get to my question or to get to my answer to the question. So what it says is, how much more did she spend on crystal beads than wooden beads? Well, let's think this through. This is to answer the question now. Let me switch colors. It looks like she spent 20 cents for my wooden beads, or for her wooden beads, which was our x value. So 20 cents times 75 is what? That is $15. And then also she spent 50 cents on, and maybe I should just label this the wooden beads. So wooden and crystal, or I guess should use x and y, but we can use the same. We can use these two variables just to keep our thoughts organized. So that should be 50 cents times the 52. Which is $26. So how much more did she spend on crystal beads? Well, it's great that we're finding that she spent more on crystal beads than wooden beads, 26 compared to 15. We just need to figure out how much more. So $26 minus our $15 gives us a total of $11 more spent on crystal than wooden beads. Sorry, I'm squeezing this in at the bottom. And this should be my final answer. So we'll just box this guy in and just star it.